Thanks for joining us and welcome to the Hopsteiner Webinar Speaker Series, Hoppy Topics. My name is Darren and I'm part of the success team here at Hopsteiner. The Hopsteiner Webinar Speaker Series, Hoppy Topics, is a free online educational seminar with presentations from our lead researchers and hop scientists. Each presentation was created to address hop-related challenges brewers face on a daily basis, and we hope their latest discoveries help you in your quest to brew better beer. I'll host a new speaker with me here every Tuesday this month to keep you up to date on industry trends and helpful insights. Under current stay-at-home orders, we hope these presentations help bring supportive inspiration to your lives and your craft. Before I introduce you to our guest speakers, everyone should know that comments and questions are absolutely welcome. Each will be addressed at the end of the webinar using the Q&A tab at the bottom of your screens. A link with each webinar recording will be available on our website under the online customer portal page shortly after each presentation. Simply sign up on our website to watch or download. And without further ado, here with us today is Frank Pfeiffer, Technical Director of Product Development at Hopsteiner Germany, along with our questions moderator, Mike Sutton, Vice President of Craft Sales. Frank started his brewing career 35 years ago after receiving his degree as an engineer in brewing science and beverage technology. Prior to his career at Hopsteiner, Frank worked at the Weihenstephaner Brewery as Director of Operations. Frank currently supports R&D activities at Hopsteiner for new product development and technical applications. In his most recent 20+ years in the field, Frank has served as a trusted advisor for the Master Brewers exams at the IHK in Munich and as a technical confidant to breweries both large and small across the globe. Also here with us today is Joe Pulowski, Quality Labs Manager at Boulevard Brewing Company in Kansas City, Missouri. Joe is an accomplished instrumentations tech responsible for bringing quality to every can through testing and data analysis. Joe earned his bachelor's degree in chemistry from SIU and his master's from the University of Missouri in analytical organic chemistry. Joe has been with Boulevard Brewing Company for the past 15 years, overseeing quality assurance in all aspects of the brewing process. Joe is a member and chair of the board of directors for the technical committee of the ASBC and has spent just as long in the brewing industry as he has as an environmental chemist, only he likes to drink his samples now. Joe, Mike, Frank, thanks for joining us.
Yes, thanks, Mike. Thanks, Darren, for your very kind introduction. And good morning and good day here from Germany. So today I want to give some information about our research that we did regarding the impact coming from filtration on aroma compounds, on hop aroma in dry hop beers. So we will we will talk about why we need, or why some people need filtration on dry hop beers. Some years ago, I never had the idea to talk about this or to make research on this, but we have seen from the last years that it's very common, depending on the area where it is, but it's very common to filter some dry hop beers. And I was very interested in how this filtration process influence or can influence the hop aroma compounds in those beers. I will talk a little bit about the trials that we did. We made some trials at the university in Weihenstephaner, and so I decided to use dry hop beers from a very big German brewery. It was produced in a big volume, so we were able to handle also a certain volume as a, let me say, as a medium level dry hop, medium level hop aroma compounds inside. So good base beer to make filtration. First trial was done with the with pure diatomatic earth Kieselguhr on a candle filter system, and then we used the same beer again from first filtration to use it on sterile filter sheets in a vertical filter system. And after the conclusions coming from this test runs, from these trials, I will also start a short discussion about alternative to filtration. What else can we do to remove cloudy compounds from the beer, from dry hop beers, with alternative methods, especially talking about centrifugation there. So this picture you already know, that is made from lupuli glands inside of a hop cone, and you see the small yellow bubbles with a very soft and fine skin outside, and they contain the worth-giving compounds regarding brewing. That means there we find the bitter compounds and we find the aroma compounds. And now we know different ways to bring in the hops, to bring in this elements from the hops. And yes, regarding the point of addition, we find more or less, let me say, extraction on the bitter side or extraction on the aroma side. So why do people filter dry hop beers? Yes, we want to extract as much as we can of this, not cheap aroma compounds into our dry hop beers. And why do we want to make filtration? Why do we want to eliminate all these natural looking hazy compounds? But it's, this also comes from customers in different regions all over the world. And we know from Germany, especially in East Germany, and from our neighbors in Austria, and from Asian people, from South African people, and a lot of them, they like clear filtered beers. They don't want a turbidity in the beers, but they also want to taste the or find the attraction in a kind of IPAs. And so that's one reason why we can filter, or we have to filter beers, even when they're dry hopped. And it's also when you sell your beers on the market, in supermarkets, on the shelf, some of them, they expect a long-term physical stability without any clouds, without any settlement in the bottle. And if that's a fact, you have to do something against this to make your beer more stable. It could be that it's a little bit cloudy by nature, but to control the cloudiness, the haze in your beer, that's always a challenge, to make it long-term stable, that it does not settle down, or that more of this haze occurs there on the shelf. What we have seen at the beginning of this, let me say, craft trend all over the world was that a lot of beers were very, very hazy at the beginning on the shelf, and then after a while, the haze collapsed and the particles settled down as sediment on the ground of the bottle or on the can, and that doesn't look very nice. And often we have the effect that when you pour the beer in a glass, you see that some small flakes or particles are also transferred from the sediments from the bottom into the glass, and that doesn't look nice, because these compounds go up and down, and that's not good for the drinkability of these products. And it could be, that's one thing we have to think about. It could be that it's also a creative tool to change a beer, a dry hop beer, to give it a new kind of character, because something happens in filtration. That is what I want to show you now. At the beginning, again, this slide is a little bit to warm you up, to bring you a little bit deeper into this topic of hop aroma compounds. We all know these compounds, the monoterpenes, the sesquiterpenes, and these compounds are, let me say, normally only introduced in dry hopping into a beer. In regular production, if it is late hopping in the brew house, in the whirlpool, for example, they are normally evaporated, or later on they are eliminated in fermentation through the CO2 gas that is leaving the tank, and also by yeast cells that goes into contact, especially with this very volatile compounds like myrcene, limonene, and alpha and beta penin. Even if there are a lot of high dosages coming from hop additions, especially regarding the myrcene concentration, you find relatively low concentrations in regular beers at the end. It goes to zero, nearly goes to zero, and they don't have any impact on these beers, but in dry hopping, there's a good transfer rate of myrcene coming from these hop additions. The sesquiterpenes have one problem, that is the threshold that you need to have a noticeable aroma in your mouth is very high. And it's nearly, let me say, it's not impossible, but it's hard to achieve reasonable concentration, especially regarding beta-carotene and humulene, that you can taste these compounds in the beer. Then you need something very heavy dry hopped, like a New England IPA, where you can reach such a high concentration. Farnesene is something that shows, let me say, gives more information about the origin of the hops, about the variety of the hops, but in all these beers that we found, we had no impact of farnesene regarding values over the threshold that you can taste this compound. Coming to a very important group of hop aroma compounds, so-called monoterpene oxides. These are alcohols, and by the fact that these are alcohols, they are very good soluble in liquid, in beer especially, and the volatility is not that high. So if they are once introduced in the beer, you can also find very good levels later on after production, at the end of production in your container. The importance is relevant in late hopping and in dry hopping as well. And among each other, they have also some additive effects because their aroma impression is not that different from one to another. And if you find linalool and also a certain amount of geraniol, so they both improve or increase the aroma effect of these compounds. It's going to direction of citrusy and also fruitiness and flowery. The aliphatic aldehydes and ketones, they are also volatile, but some of them are noticeable under very low concentrations. And in dry hopping, you have reasonable transfer rates to get these typical fruity and flowery notes on your palate and in your nose. Now coming to the autoactive thiols, now we have compounds where sulfur is involved. And what we know about sulfuric compounds is that they are very, let me say, very good, noticeable even at very low levels. All the other compounds to describe reasonable concentrations, also the carbolic acid esters, we are talking about microgram per liters, and here for the thiols, we are talking about nanogram per liters. And we need only some nanogram per liter, especially for the 4-MMP, and this gives an impact of, let me say, blackcurrant taste and blackcurrant flavor. And the 3-MMP here, especially to find in Nelson Sauvin, that gives this typical white wine-like flavor on this, coming from this hop variety. And they are volatile. That means the impact coming from a brewhouse edition is maybe not that much, but we find a lot of them, or we can find a lot of them depending on the variety in dry hop beers. And what we also think, we do not know it exactly, but we think that we have a form of precursors, of thiol precursors. That means that these thiols are bound to a sugar molecule, for example, and later on with the help of yeast enzymes, they are released. And then even with thiol precursors coming from late additions, let me say addition into whirlpool, we can find something later on that was released by a yeast cell from a thiol precursor. The next group is also very important. Now we're talking about the esters. A lot of natural esters we find in the nature, and they also have their own special impression in hops and also in other kind of foods. And it's always when you're searching about a flavor impression, you come more or less to this group of the carboxylic acid esters. They are not that volatile. That means that we also find something of that when we have a late addition in the brew house. So some of them are transferred and they have an impact on this typical late addition hoppiness in the beers. And they're also very important regarding dry hopping. And we have to know that all these compounds work together to help to explain aroma expressions regarding fruitiness, regarding flowery nose, regarding citrusy, and so on. With all these compounds or group of compounds, we can find solutions in nature and also in food, and not only in beverages. So now it's coming to the filtration itself. We got some ideas about this when we were in contact with a brewmaster from a brewery very close to us. It's also a craft brewery from 1630 here in the Bavarian area. And the brewmaster said, okay, I have filtered my IPA. It was not a typical American IPA, but it was, let me say, German IPA, and not that heavy dry hopped. But he said, okay, my beer is now completely different after filtration. And he said, okay, just send me sample of the unfiltered one and the filtered one. And then we do our measurement here in-house in Mainburg in our laboratory, because we are able to analyze around 25 different hop aroma compounds in beer. And that's what we did. And here you see the results. And especially when we have a look on myrcene, when we have a look on the beta-caryophyllene and on the humulene. Here we found very high losses. So between 70 and 80% of these compounds were eliminated by filtration. And that's a lot. If we know that myrcene threshold is around, some people say 150, some people say 400 microgram per liter. So it was noticeable here in the unfiltered beer, and it was not noticeable anymore in the filtered one. So it's a big difference that also has an impact on the complete flavor impression of this kind of beer. Let's go to another group with a very good solubility, with a very good polarity, the terpene alcohols, where we measured linalool and terpineol. And here we measured also the citronellol and the geraniol. And make it short, the result was that the losses were not very high. Here in terpineol, we found 10% less than in the unfiltered one, but for linalool especially, the losses were only around 2.6%. And to have one eye on the analytical deviation, we know that these losses are not really present. Some compounds like the ketones 2-decanone and 2-undecanone, they behaved a little bit different. We have more losses here and less losses on this compound. And regarding the esters, ethyl-didecanoate can also have a big impact on flavor, on fruitiness in beer. Was also reduced heavily by around 60%. And another one, like the methyl-butyl isobutyrate, was nearly not impacted by filtration. So I think it behaves a little bit on the molecule structure the compound has, if the filtration has an impact or not. So that was the first information that we got out of this, let me say, pre-trail. And then I had the idea, okay, now we do something by our own. We make it a little bit more scientific, if it's possible. We used the beer from a Northwest German brewery produced there with our Hopsteiner variety 09326. And there was a kettle edition and a whirlpool edition with these hops, and then later on an addition of 250 grams per hectoliter in dry hopping. So my idea was to make a filtration with these dry hop beers just with Kieselguhr. No other compounds impacted the filtration like cellulose or any stabilizer like PVPP in filtration system. So we used a candle filter system from Filtrox, very simple one. It was one long candle and in a glass cylinder. And there we made the filtration with pre-coating with the coarse Kieselguhr from Beko 3500. And then we used the fine one for second coating and for the running dosage Beko 200. And you see we have a very low filtration rate, but it was very effective. The beer that came in was very cloudy. We had to dose around 150 to 200 grams per hectoliter because a lot of sediments came with the beer, a lot of cloudy compounds came with the beer, and to keep the filter open for a certain time to get out a certain amount of filtered beer at the end. So now I want to show you the results that we got from this first filtration run. And these beers were also analyzed here in our laboratory with the method HS trap GCMS to find the hop aroma compounds in beer. So first result, that's regarding myrcene. On the left column, you see the unfiltered level that was over 1400 microgram per liter. And here after 1 hour and after 2 hours and after 3 hours of filtration, we see that it's clear that we have a lot of losses of this hop aroma compound due to filtration. What we did is that we collected the beer over the first hour, then we collected the beer over the second hour, and we collected the beer over the third hour. And from the average, let me say the average sample of this filtration hour, we made our analytics. So it's completely the result, or clear the result of the average amount of myrcene in this first filtration, second or third filtration hour. Have a look on the beta-caryophyllene. We know also that this compound is also very non-polar. Non-polar means it does not like to stay in this kind of liquid in beer. And so we often see that these compounds like myrcene, caryophyllene, and later on you see the humulene, will try to find a way to disappear from our beer. We got the same result here for beta-caryophyllene. To be honest, that's not a very high level, but it was a level that we were able to measure. And also we found the same losses here during these 3 hours of filtration. Result for humulene was the same. So we can say all these non-polar compounds, the more volatile myrcene and also the volatile beta-caryophyllene and humulene was drastically reduced by filtration just with Kieselguhr. Then we go to one of these esters where we found also losses for the ethyl dodecanoate. Normally the threshold is a little bit higher, it's around 70 microgram per liter, but the result was the same. So we found some losses due the filtration process. The same for ketone undecanone, that has an impression around 6 to 8 microgram per liter. You can smell and taste it, the fruitiness. So when you reduce this level going down in direction to 6, could be that the aroma impression is also reduced by filtration. And now we go to linalool. Small or slightly losses here in the first and second hour. The third hour was the same value that we had in the unfiltered one. So we can say the impact on linalool is not that high, especially for our terpineol. The impact was lower than for linalool, and we can say it's more or less also with an eye on the analytical deviation. We can say it's a constant result here from the unfiltered one to the filtered beer after 1 and 2 and 3 hours. To bring it together on one slide, it's nearly exactly the same result that we got in our trial compared to the, let me say, pre-trial coming from a brewery over there from our area. For myrcene, 75% losses. For the beta-caryophyllene, the highest losses is 80, and for humulene, 76%. And we also found losses here for the ethyl dodecanoate and very low losses here for the 2-methyl butyl isobutyrate. So if we have an eye on all these numbers, we will see that we have found the same effect here in our microfiltration compared to the big filtration there in the industrial brewery. Then I said, okay, now let's divide this impact on certain aroma compounds by filtration into 3 groups. It's group number 1 with very high losses. And we've seen here the flavor activity of myrcene. For me, it's the highest one out of these 3. And we see here we had high losses on a very high flavor active substance. Coming to the medium group in the middle with some more or less losses, we have a lot of these esters involved and 1 ketone. And they also have an impact on the flavor, and but not that much as for myrcene and for linalool, for example. And the third group with nearly or no losses for the isobutyl butyrate or very small losses regarding terpineol, some losses on the linalool. So we have now 3 different groups impacted more or less by just filtration with Kieselguhr, with diazometic earth. So the next trial was to use the beer from trial number 1, the pre-filtered beer, and to homogenize it and then to start a filtration over filter sheets. A sterile filter filtration we did with a special plate coming from also from Beko company. And this plate shows no other components than cellulose material. There's nothing else inside. We have no Kieselguhr in this plate, in this filter sheet. We have no stabilizer in the filter sheet. It's just 100% pure cellulose. And that was something I had in mind before we started this. I said, okay, I think that the cellulose material must have also an impact on some compounds here on this filtration in the safety filtration machine. Then we did the filtration, and the results that we get came as well from the laboratory with the GCMSMS system. And here, to give you explanation about this picture, here we have the unfiltered beer, and that's the concentration of linalool in green, and in brown, the concentration of terpineol. We see from the unfiltered one to the average values after filtration. So we blended we mixed all the filtered beer together, did the analytics, and here you see the input or the impact on linalool and also on terpineol is minor due to this filtration with diazometic earth. And then we go to the sterile filter system, and then we measured after 1 hour of filtration, after 2 hours of filtration, after 3 hours of filtration, the same that we did before with the Kieselguhr filtered beer. We collected the beer over 1 hour, 2 and 3 hours, and then of this sample we took an average sample and made our analytics. Unfortunately, we were not able to filter longer because we were running out of beer here on the filter sheet system, and that was the reason why we had to stop after 3 hours. Normally, it must make sense to go 3, 4, 5, 6, 7 hours and have a look on what happens there later on in filtration. But we got some very nice results there, but not on all the compounds, but on some special compounds. Here, this is a ethyl dodecanoate that was also showing losses by the diazometic earth filtration. And then we measured after 1 and 2 and 3 hours in the sterile filter system, we measured different values. Oh, I said, what's going on here? The lowest value is in the first hour, and then it goes up like on stairs. And in the 3rd hour, yeah, we come much closer to the value that we have in the average beer before filtration. So I think if there were another 2 or 3 hours of filtration, we were able to come to this value again. I think that the filtration material, that the cellulose material is able to absorb this compound. And when you have a kind of saturation in the filter sheet, you see that you find at the end more or less the same values or the same levels of concentration on the certain compounds. That is what we found regarding the ethyl dodecanoate. That's also what we found regarding the myrcene. You see here the impact from the Kieselguhr was very high, but here in the first hour of filtration we found much lower levels again, and then these levels were rising up. I have no explanation about this level because this one is higher than the beer that was coming in. But have a look on the analytics. It's not so easy to detect always the right concentrations of this compounds in beer under such a low concentration in the level or in the area of microgram per liter. But you see the tendency is the same than for the compound that we discussed before. We found the same tendency here also for the 2-ondecanone. It was always also the lowest level here in the first hour. Then slowly it was coming back to the basic concentration coming from the pre-filtered beer. And I said, okay, now we have seen something special there on certain aroma compounds. So what happens with our bitter compounds? And we first measured the EBC bitter units, and we found, yeah, it was a slightly impact also on the bitter units that we found lost a little bit, around 2 or 3 bitter units we lost here on the complete filter system, and the losses from the de-filtration to the safety filtration sheet was not that much. But we also had a deeper look into the singlet compounds, and regarding the iso-alpha acids, they are normally in a very good soluble. They are good, have a good polarity in the beer because of their isomerization form of the alpha acids, and we also had some slightly losses there due to Kieselguhr and due to the filter sheets. Now let's have a look on the alpha acids, because what we know is when we have a dry hopping or we make dry hop beers, we also bring alpha acids into the beer again. When we have a beer, let me say a traditional beer brewed in the brew house with the hops, the level of alpha acids finally after filtration will be something around 1, maximum 2 ppm or milligram per liter, not more. But when we have dry hopping, we bring alpha acids into the beer again. We also bring so-called humulinones in the beer again. They have a very good solubility, like the iso-alpha acids, but the solubility of the alpha acids, or let me say the polarity of the alpha acid, is bad. And that shows also here the result of filtration. So there is a big impact here coming from the Kieselguhr, and there's also an impact here later on coming from the cellulose material from the filter sheets. And in total, we have losses of the alpha acids around 50%. And that maybe has a little bit impact also on the bitterness or on the bitter profile of this beer. So I was also interested to see how the alpha acids behave in the sterile filter. And yeah, to be honest, we got the same results here. It goes into the same direction, that we have lower levels at the beginning of the process than later on. And I think that also this, let me say, non-polar alpha acids, they are bounded and absorbed by the filter cellulose material until a point of saturation. So let me bring it together. We have seen that both filtration trials with DE and also with the sterile filter sheets, they have a very high influence on the composition of beer aroma compounds. And we also know that the more non-polar the hop aroma compounds are, the more losses will occur by filtration with diatomatic earth. How can we describe it? With the diatomatic earth, we have a kind of, let me say, deep bath filtration. So normally a compound, a very small compound, for example, like myrcene, if it's in a solution, it's never been attracted by Kieselguhr and eliminated by Kieselguhr filter. It normally goes through the Kieselguhr filter without any problems, but it must be connected to something else so that the Kieselguhr has a chance to remove these compounds. And that is something that we now already know, that a lot of non-polar compounds from the hops, not only aroma compounds, also bitter compounds like the alpha acid, they stick on microparticles, and these microparticles, they are filtered out, for example, with such a kind of Kieselguhr filtration. And the sterile filter sheets, again, they seem to absorb some hop aroma compounds and also the alpha acids coming with the beer. And that means that behind these filter systems, we have different qualities of beer on different moments. And that needs to homogenize the batch, if it is possible, at the end of the filtration in the BBT, or at latest before the filling. And otherwise, we will find different qualities in our bottles or in our cans. And I think that is very important result coming from these trials. Okay, now coming to an alternative to filtration, that is the centrifugation. So we have another process that's also possible to remove haze, also to remove some hop particles, not all the hop particles, because that is very high load for the centrifuge sometimes, but at least the machines are built to clear up the beer from hazy compounds. And this is one example here. This is a machine from Flottbeck that we used for a test trial in our technical department here in Mainburg in our research brewery. And I wanted to know how, or is there any influence coming from centrifugation on this aroma compounds that I mentioned before in these filtration trials. So I make it short. I bring all these results together on one slide. So what we did is we prepared a BBT with a very cloudy beer. And this cloudy beer also had a very high concentration of yeast cells. That was around 8 million cells per milliliter. Looking like, let me say, a fresh dry hop beer where we have also the impact from fermentation because we have a relatively high concentration of yeast. And then we started to run the centrifuge, and we took samples from the beer that was going in the centrifuge and from the beer that was going out of the centrifuge at the same time when we started the process, in the middle of the process, and here after 106 liters at the end of the process. I have to say that when we filled the beer in the tank, we homogenized the beer with CO2 when everything was in, and then we tried to start the centrifuge. Unfortunately, it was not able to start it directly. We had a lot of problems with electrical power and so on and so on. So the beer was standing there in the tank for several hours before we were able to start the process. But maybe that was our luck, because you can see here that the relatively losses differ over the time where we took the sample. For myrcene, I want to explain it. For myrcene, compared to the myrcene input before the machine, we lost 90% of the myrcene, or was lower 90% of the myrcene in the beer behind the centrifuge. In the first hour, at the beginning, and then in the middle, it was around 60%, and here it was a little bit more than 50% at the end when the process stopped. And this we found for all this, let me say, more or less high volatile hop aroma compounds. Beta-caryophyllene, farnesin, humulene, and also for beta-limonene. So the results were very close together. The retention rates were not the same. You see here for limonene especially, we had values between 58% and only 30%. Not that much than for the beta-caryophyllene, for example. But on the other hand, have a look on linalool and also have a look here on terpineol, geraniol, citronellol, the whole terpene alcohol fraction that we know from the hops. They show more or less no changes. Some changes were detected, but let's think about the sampling and also think about the analytical deviation. So that's nearly nothing. But that was something. And how can we explain this picture? What is the difference here in between the beginning, the middle, and the end of the process? Because the removement, the losses at the beginning were much higher than the losses here at the end, in the last liter of the centrifugation. What I think is, at the beginning, we have seen a very cloudy beer. Some hours were enough for the compounds, for the haze compounds, to settle down again in the tank. And we have seen that in the inlet of the centrifuge, the beer was very cloudy at the beginning. And the more and more the experiment was running, the beer was getting more and more clearer. But that doesn't explain, or doesn't help to explain this anomalism here. What I think is that regarding the fact that we know that very high volatile compounds try to set to a small particle, and that is the only way how the centrifuge is operating, that by G-force particles are removed. If these compounds like myrcene are setting free in the liquid, you have left no reduction or no losses on myrcene by centrifugation. So it must set on a particle, and I think that the saturation of the particles was such high at the beginning, in the slurry, in the bottom slurry of the tank, that most of this myrcene was connected to this particle and removed by centrifugation. And going back to this value where it's a little bit more than 50% losses, that means that also some of the myrcene was not connected to a particle there on the top of the tank, because the beer was much clearer there coming out. And so maybe there was free myrcene that was not able to find a partner to connect and then to remove by the centrifugation process. So that is my explanation regarding this. And we are looking forward to get more information in the future. We are running some more trials, and I think that after this COVID-19 disease, we will keep on going this and find more results on the impact coming from centrifugation on hop aroma compounds. So now I give the word to Joe, and Joe will talk a little bit about his results he got from trials he did some days or weeks ago about centrifugation.
Thanks, Frank. Welcome, everybody. A week ago or so, I was contacted by Mike Sutton, and he asked a very simple question. Do you have any data on hop aroma loss for IPAs, especially in dry hop beers? And of course said, yeah, we've got lots of information on that. We actually use that for developing our processes here and timings and so on. And he said, can you share any of it? And I said, yeah, I've got some to share, but you know what, I'm doing a filtration run today. Maybe we could work out something really quickly today. And we sat down and we talked about what would be interesting. And the beer that we were filtering was Space Camper Cosmic IPA. That's one of our newer beers here at Boulevard. The beer is a blend of 5 different hops in the dry hopping. It's added mid to end fermentation at approximately 2 pounds per barrel. Static addition on the top of the beer. This beer was actually produced in 2 different fermenters and then blended together to make the single bright tank that was used for packaging. As this added mid-fermentation, we allowed the fermentation to complete or to continue and complete until we hit terminal gravity and made sure we weren't going to have any issues with any unknown things happening later on in the package. But basically what we did was we opened up the 2 fermenters after blowing out the hops at the end of fermentation and residual yeast that was there as well, and transferred those at the same time simultaneously to our centrifuge. Through the design, we decided we'd get samples that were going to be coming from right before the centrifuge as they're coming in the pipe, feeding into the centrifuge, and then after the centrifuge. And I'm going to take multiple samples as we rolled along. The timing on that is pre-centrifuge. We'd take a sample, and then 10 minutes later we would take a sample from a collection point just after the centrifuge, and then we wanted to follow that all the way to the bright tank. And tanks being what they are, there's a minimal amount of volume that you have to fill before you can actually get a sample. So we collected a sample approximately an hour after we collected our first pre and post samples. And like I said, we took we took samples from pre-post and bright tank every 2 hours after that until the end of the run. And then we finally finished up with an analysis of the bright tank the day after the tank was all the way full, and followed that up when it went to the can line, to our can line, and filling 12-ounce cans, and actually measuring those during the sample or during the packaging run as well. Our analysis that we do here is headspace, solid phase micro extraction, GCMS, working in the sim mode. You can go ahead and switch the slide. So I'd like to show you some results that we see. And again, this is all pretty much hot off the press, just within the last week or so. It kind of mirrors what Frank's been already talking about, especially in the centrifuge area. The compounds that you see right here with we have samples that are coming through with the blue pre-centrifuge, and then post-centrifuge, and then bright tank and final package. When Mike first asked me if there was what did we see when we did dry hop beers, I said we actually see an increase. We see a modest increase in sample or in aroma compounds that come after centrifugation. That's measuring at the bright tank. The thought behind that is that in centrifugation, as the particles or as the beer is spinning around, the hop particles are coming in, are being fed into the centrifuge as well, and there's a little more mixing and perhaps a little more extraction of some of those hop aroma compounds as they're going through the centrifuge and into the beer column. And that's generally what we saw, or what we have seen in the past, is a modest increase in actual compounds. But if you look through the data that's presented here, as it's presented, you can see pre-centrifuge, we had all the blue lines being our marker compound, and then we do see some losses, or we do see a minimization or a slight, not a slight, a very good decrease in some compounds post-centrifuge and then hitting the bright tank. Our package levels that we have, though, are pretty much right where we expect them to be, and they level off. The terpenyl alcohols, geraniol, linalool are the best example. They are fairly stable compounds, and they're going to hang around, and so we don't see a loss of those. The myrcene that Frank's already talked about, we do see a pretty significant loss of myrcene, but this mimics what we've seen in the past. Let's go ahead and move on to the next slide. All right, so I mentioned that we don't really see a loss generally in centrifugation going to the bright tank. But this graph is kind of complicated, but it is interesting. It breaks it out by the pre-centrifuge and then the post-centrifuge and bright tank and the actual packaging runs. The pre-centrifuge, you can see the levels in terms of ppb on the left. Pre-centrifuge, the beer is fairly good, being dry hopped at 2 pounds per barrel. The very flavor active hops, or aroma active hops that we're using in our process generate some very decent levels. Post-centrifuge, we did see a decline in most of the compounds that you see there. These are the main marker compounds that we're looking at. So we're looking at the myrcene for nonpolar compounds, linalool and geraniol for more of the terpenyl alcohols, just to see what's going on. And then we also had some esters that we wanted to throw in to try and check and see what's happening in the different classes. As you move through the bright tank portion right there at the start of the bright tank, so the bright tank is only, say, 100 barrels full. The next point on that at medium is going to be 300 barrels full, and then end is going to be about 500 barrels full. And you can see that compared to the initial pre-centrifuge, that you do have a loss of compounds as you go through time. The bright tank full sample that you see right there is basically, it's a sample that's being pulled directly from the Zwickle, which is into the beer column, which is in the lower level of the bright tank, approximately 100 barrels into the bright tank. That was measured the day after all of the other bright tank samples were collected. So that's about 24 hours difference between that sample and all the 3 other ones. As you look at the concentrations of that, we actually see an increase from what we had on the pre-ferment or from the pre-centrifuge samples. And thus my response to Mike, yeah, we don't really see a decline in hop compounds or hop aroma compounds. We generally see an increase. So this is a normal sample point for us. Taking that just a step farther, looking at the packaging run, as we were performing the packaging run. The first sample that you see is the start sample. That's within the first 15 minutes of the package run, once dissolved oxygen and all the can quality product or can quality parameters are taken care of. When the beer's actually running, getting a sample, that's one of our first samples off the line. Lucky for us, that goes for largely employee beer, because we like to clear our lines and make sure we have good beer going out. But after that point, 2 hours, 4 hours, 6 hours, 8 hours, it's very consistent in terms of the concentration of the compounds that we see in aroma. Going back to that start sample, it matches pretty darn close to what I saw at my Swickle in my bright tank. The reason that I'm bringing this up and I wanted to show this is that this is why it's most likely important that you homogenize the sample in your bright tank before you send to package line, because if you don't, then you will end up with a slightly non-homogeneous beer being packaged. So I believe that's all I wanted to share with you today. Is there another slide, or are we at the end? We're at the end. Good.
Okay. Joe, thank you very much. And Frank, appreciate the very informative information. So we'll go ahead and open up to the Q&A time. Frank, for you, the question is, what type of filter was used for your test? Is there a difference between different type filters? For example, plate and frame versus candle versus membrane?
Yes, that's a good question, Mike. We did this filtration try with the DE on a candle filter, so that's only steel, where we have a pre-coating with coarse kieselguhr, and then we start with fine kieselguhr coating and dosage. So there's no other material impacted. When you have a kieselguhr filter with a cellulose plate, you find it often, then you have also some cellulose material that can maybe impact also the results that you find, especially at the beginning of filtration. But this time I was really looking for a filter system where is nothing else involved than kieselguhr. Another system can be membrane filtration. So I was searching to find a supplier for membrane filters to work together with me, but they were not that much amused about this to open the cards. So I'm still looking for a brewery using membrane filtration on dry hop beers, but that is something that's not very common.
Okay. Another question related to the trials. Did you do clarity measurements with each method?
No, we have no clarity measurement. We have no hazy meter or turbidity meter at the filter.
Okay. Joe, question for you. How do you homogenize bright tanks prior to packaging?
One solution that you can do is pumping CO2 through the tank to try and push it and cause movement within the tank to try and blend it.
Okay.
If you're lucky enough to have a mixer in the bottom of your bright tank, that's even better, but not very many people do.
I guess another option could be to pump, transfer the tank to another tank if you have the luxury of extra tanks.
Yes, if you have the luxury of extra tanks.
Yeah. Okay. Frank, for you, what impact does DE sterile filtration have on thiols in the beer?
It's a good question. You have to remember we did these trials in 2017, and there was no real method to measure for good measurement of the thiols. Now we have it. I think that's the thiol, to measure thiols wherever they are, coming from the raw hops into the bottle. That will be the next challenge that we find here in our research and development department.
Okay. Next question, could a brewer supplement the loss of nonpolar hop aroma compounds post-DE filtration using hop oils without impacting the flavor?
Yeah, it's worth to test it, but it's also the dosage of the hop oils is very important to find a balanced product. I'm not a friend of dosing hop oils. I'm talking about variety specific hop oils right there at filtration, or especially not after filtration, because that's a point where we don't dose anything else further on. But it may help to a certain point, but it needs a test.
Okay. Frank, for you, what about using fining agents? How much does that affect the results in comparison to filters?
It's also a project for the future to see how the PVPP and the Kieselgel, hydrogel and xerogel is working on this hop aroma compounds. I know, we all know that they have an impact on proteins and on polyphenols, talking about PVPP, and they are used to increase the color stability of the beer. But I have no idea how they work on aroma compounds.
Okay.
But it's also, yeah, you see there's coming more and more projects up here from the discussion. That's nice.
Yeah. I guess this one can apply to both you, Frank and Joe. What is the best way to reduce crop year variation in hop aroma compounds? Joe, you want to kick it off? What does Boulevard do to try to minimize?
Frank, I thought you were going to take that one. Well, what we do is we get samples of new hops that are coming in and compare the aroma compounds that we have from the new hops that are coming in compared to the old, and do some brewing trials and see if we need to do a dosage adjust, increase the number of pounds or reduce the number of pounds per barrel in order to get there. It's all combined analytical and sensory.
Yes. So my idea is to make it in easy trials, make a small amount in a keg where you put the hops in from the last crop and from the next crop, the same amount, and then you compare how is the aroma present coming from the hop oils, and then you can talk about an adjustment. And then what you can also do is to add different values or different amounts of hops into kegs, where you can also blend, that you can mimic different hop additions in between something very low and between something very high, to find a balance when you compare this with the beer that you produced in the past.
Okay.
That's easy to handle. You can make it from one brew, so all the base beer is the same.
All righty. Frank, question for you. How does beer stabilizers such as silica gel or PVPP impact hop aroma compounds?
Yeah, that's close to the question I had before. So that's something we have to find out, to make trials again where we see how these compounds behave. So far as I know, going back to the pre-trial that was coming from a commercial brewery in Bavaria, this guy, he used a one-way PVPP, and he also used hydrogel on this filtration trial. But when we compare the results from his filtration and from our DE filtration, the values or the losses are very similar. So it looks like the impact is not that much, but we have to prove it.
Okay. Kind of a follow-up question regarding filtration. Do you have any experience using perlite instead of diatomaceous earth in trials?
No.
Okay.
No.
Joe, here's a question for you, and Frank. Since most breweries don't have the analytical testing capability for measuring hop aroma compounds, if we were to test our bright beer tank for stratification, what other compounds could we measure using a spectrophotometer?
I think you may be able to, well, it depends on your beer style that you're looking at, but I think spec is one way to look at it, and certainly IBU is going to be your easiest slam dunk type of analysis. The other one that you can look at if you're torn on, or if you want to stay on spec, doing a color analysis, looking for haze or looking for increased turbidity as you sample your beer.
Okay. Well,
Yes,
gentlemen,
yeah.
go ahead.
Mike.
Go, Frank.
No, last comment on this. Yeah, one quality parameter is the haze, as Joe mentioned before, and yeah, some centrifuges. If you have a centrifuge, they have the ability to measure the turbidity in the outlet, and that is something that helps you to control the process. So if your haze goes up, you have to reduce the speed, and so the beer stays longer in the drum, and you have more impact on the removement of the hazy particles.
Okay. Well, gentlemen, thank you so much for responding to the questions. And Joe, I just want to extend a special thanks to you and the Boulevard team for your diligence on running those trials and providing the information for us. So I'll turn it over to Darren to go ahead and wrap it up.
Yeah, I'd also like to echo Mike's results there and comments. Thank you, gentlemen, again, Joe and Frank. That wraps it up for today's webinar in our series of Hoppy Topics. Our next presentation will be right here at the same time next week with our hop geneticist Nikolai Petra and Dr. Paul Matthews. This is a fan favorite for brewers and hop nerds alike, as our hop breeders will be discussing the science and application in which we use to create new hop varieties. As always, our recordings can be found on our customer portal page on our website. Once again, my name is Darren. Thanks for joining us, and happy brewing.